So once you have understood Jacobi method, let us talk about Gauss Seidel method. Now to solve that, what you are going to do is you are going to solve this equation. Let us solve this problem. So this is the problem that you are going to solve. Again, what you are going to do is you are going to generate the equation of x1, you are going to generate the equation of x2, you are going to generate the equation of x3 from equation 1, 2 and 3. So x1 is let us say again k plus 1, it's going to be 7.85 plus 0.1 x2 plus 0.2 x3 divided by 3. x2 is going to be minus 19.3 minus 0.1 x1 plus 0.3 x3 divided by 7, and x3 is going to be 71.4 0.3 x1 k plus 1 plus 0.2 x2 k plus 1 divided by 10. Okay, let me erase this and I'll explain you why I wrote k plus 1. So in Jacobi method, what we used to do is we used the values from the previous iteration. That means when I said find out the value of x1 for the next iteration, what you did is you use the value of x2 and x3 from previous iteration. Okay, but now in Gauss Seidel method, what you are going to do is you are going to use the value as it gets available. Okay, that means let me solve it here. So again, let us say that this is the problem I. Okay, now for this particular problem I already know the true solution. The true solution for this particular problem is x1 is equal to 3, x2 is equal to minus 2.5 and x3 is equal to 7. So let us solve this problem. x1, x2, x3, 1, 2, 3. Okay, again we'll need some initial value. So the best bet here is to take it as 0, 0, 0. But understand that this is not always true. Sometimes it will be given in the problem. Most of the time it will be given in the problem. But if you're solving a real life problem, you have to take an initial guess such that it leads to convergence. So this is this. So let's talk about the first iteration. So first iteration, what you are going to do is, so here you are going to substitute the value from the previous iteration. Okay, but now when you come at x2, you have already calculated x1, so you are going to use the current value of x1 and the previous value of x3. And when you come here, by the time you come to x3, you have already calculated x1 and you have already calculated x2, so you are going to use the current values of x1 and x2. So this is the only thing that you have to take care in Gauss Seidel method. So if you see here, to find the value of x1, what you are going to do is you are going to substitute the value of x2, that is 0, and x3 0. Okay, and this is the only value you can substitute because you don't have the value of x2 and x3 at this instant. Okay, so once you substitute that value, you'll find out the value of x1 comes out to be 2.616667. Okay, now what you are going to do here next is, let's talk about x2. Now x2, what we are going to do is we are going to substitute the value of x1, we are going to substitute the value of x3. But now in Gauss Seidel method, you know, if you see, we have two choices to substitute the value of x1. Either we can substitute this, either we can substitute this, but this is Gauss Seidel method. So according to Gauss Seidel method, whichever value becomes available, that value you are going to substitute. That means you are going to substitute the value of x1 as 2.616667, not 0. You're going to substitute 0 when it's a Jacobi method. So if you do that, you'll find out the value of x2 comes out to be minus of 2.794524. Okay. Now again, when you talk about x3, you can substitute the value of x2 and x1. Okay. But since this is Gauss Seidel method, you are going to substitute the current values. That is the value that gets available, and that is 7.005610. And if you see, the error comes out to be 100% here. Okay. Now let's move on to the next iteration. Again, for the next iteration, what you are going to do is, for x1, you don't have any other choice other than just to substitute the value of x2 and x3. So you are going to substitute the value of x2 and x3 in this equation. Okay, and you'll get the value of x1. So if you do that, you'll get the value of 2.990557. So once you have done that, now if you see, the value of x1 is available. So according to Gauss Seidel method, I'm again repeating, you'll use the value that is most recent. Okay. When you talk about x2, you are going to substitute x1, that is 2.990557, and x3, you don't have any other choice but to substitute the previous value. Okay, because since x3 value is not available yet. So if you do that, you'll find out the value comes out to be 2.499625. And again, the value of x1 and x2 is available readily. So you'll use the most recent values. So you'll calculate the value of x3, and you'll find out the value comes out to be 7.000291. And if you calculate percentage error, it comes out to be 12.5%, 11.8%, and 0.076%. Okay. Now we were lucky here that within 2 iterations, we found the value which is very close to the true solution. Okay, that is not going to always happen. You will be doing much more than this, more iteration than this, and there will be a predefined criteria. Okay, that the approximate error should be less than 5%, less than 3%, and so on. So this is your Gauss Seidel method. So again, if I repeat, in Jacobi method, what you do, you use the previous values. In Gauss Seidel method, the only change what you do is, only difference is you use the most recent value. If it is available, good. If it is not available, then you are bound to use the previous value. So this is your Gauss Seidel method. Now one more thing, let us talk about the convergence of Gauss Seidel method. Now if you see here, if I shuffle this equation, okay, if I shuffle, like if I make the first equation second and the second equation as third, the whole Gauss Seidel method will get disturbed. That means you cannot guarantee convergence. Okay. Now understand one thing, this is very important. To guarantee convergence, the matrix should be diagonally dominant. Now what do I mean by diagonally dominant? When I write down this in matrix form, this is 3, this is minus 0.1, this is 0.2, this is 0.1, 7 minus 0.3, 0.3 minus 0.2, and 10. So when I say diagonally dominant, if you see, this matrix is diagonally dominant, because when you talk about the first row, if you add this element and this element, it is much less than the diagonal element. So when this happens, when the diagonal element is greater than the addition of other two elements in a row, that kind of matrix is known as a diagonally dominant matrix. Okay. So for Gauss Seidel method to converge, the matrix should be diagonally dominant. Okay. So if I change the sequence of this equation, everything is going to change. Maybe we won't be able to guarantee convergence. But given the current equation, if you see, the equation is, the matrix is diagonally dominant. That means this particular scheme or this particular system of equation is definitely going to converge. So I hope you understood this particular thing. Okay. So just to make you understand the concept, I used two iterations, but don't be in a misconception that you will be doing only 2 iterations. It is going to be much more than that until your percentage error, approximate percentage error, falls below some predefined level.